Thought it might be useful to video these demonstrations just so you can watch it back and kind of work out how to do these calculations if you're struggling with it. So in this one I'm going to show you how to work out the input distance. That's kind of the distance that your hand would move when you're pulling this lever down. First thing I suggest you do is take your card model, line it up on the bottom of the page, and just a couple of points on the outside. And the only reason we do that is just so that if it moves we can line our work back up. So the first thing we're going to work out is this input distance, and that's the whole kind of range of movement of your lever. So set the lever all the way to the top as far as it can go. I'm using a pen really just so it comes out on the video, but I suggest you use a pencil. Now either of those right in the top, and then move it across. Obviously these card models have quite a bit of flexibility and give, so it doesn't matter if it's not perfect, but just run it all the way down until the kind of mechanism binds up there. The end of our arc, that's the start of it, and that distance is D. That's our input distance. Can actually almost do away with the model. The one thing we also need to mark is this pivot point here. Okay, we'll come back to that in a second. Just wanted to show you a slightly different technique. I know some of you have got rid of your card models, so if you don't have your card model, but you have got a 2D design sketch, you can print that on A3 paper, get a set of compasses, put the point in the start of the pivot. For this though, you do need to make sure that your CAD model is all the way, so the lever is all the way up. Start of the point, all the way around, and you can kind of work out where it's going to stop. If you imagine that lever was coming down, it would sit against this bottom edge, so about there. And again, the start, the stop, that length there is obviously our input distance. I'm going to do all the calculations on the blank sheet, but just to show you that's how you can use a CAD model, and obviously you can do the calculations on this exactly the same. So now we've got this kind of mapped out on either of these two. What you need to do is draw a line from the pivot point, so that was the middle of the kind of your pivot point of your lever, marked here. From that, all the way to the start, all the way to the end. And then you need to measure that angle in there. On this example, we're looking at 127 degrees. Okay. Now, to work out that length, I'm going to first show you the kind of the calculation method using this angle, and what we need to work out is the circumference of the whole circle. So, if we take this point here, if we took those compasses and we went all the way around the circle, we get the full circumference. Now, to work out circumference, your calculation is C, circumference equals pi times the diameter. That's D for diameter, not D for input distance. So C equals pi times, obviously the diameter is twice the radius, and on this model the radius is 16 centimeters, so 160 millimeters. Double that, 320 millimeters. Break out the calculator. Pi times 320. Okay, so the circumference of this model is 1005 millimeters. So that's all the way around. Now what we want to work out is how long just that section is. So if 1005 millimeters is the full circumference, that's the full 360, we need to work out how much just 127 degrees of that is. To do that calculation, you do 360 divided by 127, or whatever your angle is. 360 divided by 127. So that equals 2.83. So you know that 2.8 times that diameter times that input distance is the whole circumference. So now we do C divided by 2.83 equals our input distance. So 1005 divided by 2.83 found that D in this example 355 millimeters. So just when you're doing these sketches that somewhere on the page you have the values that we're looking for. Big F, the input force, we know that's 150. We've now worked out our input distance, 355. The output force is this kind of unknown, that's what we're trying to work out. And the output distance is the length that the actual can crushing part moves. So this is the output. So we'll start again right up to the top. We'll start from here all the way to the end as far as it will go to there. So this distance here, that is little d, and then in this example it's exactly 8 centimeters, so 80 millimeters. So those are all the numbers that you need. We'll have a look at how we can calculate this output force next, just to show you that if you don't feel up to doing all these calculations, all the maths, there is an easy way to work out D, which is simply taking a piece of string, laying it across that length, and you can do this either on the CAD model or on this model. Pinch it, kind of at the length it is, and then again, so there's 300, and actually this came out at 360 millimeters, which would be close enough to do the calculations with. So those are two methods of calculating your input distance. Output distance, dead easy, just a straight line, a ruler, and in the next one we'll look at how we can calculate force, the output force that's going to go onto the can.